Hello folks, this is 2021 May June paper 1-2 and the question number is 37. As from the diagram it is evident that the question belongs to current electricity. So it says a cell of electromotive force E and negligible inner resistance, so R is small r equal to 0, is connected to a circuit. The circuit has currents I1, I2 and I3. So I1 is the current in the main branch, I1 and I2 and I3 in the other branches, and PD is a V1, V2 and V3, V1 here, V2, V3. So since the PD, V2 and V3 both belong to this thing, so we must have a V2 is equal to V3. So that's common potential. Which equation represents a statement of Kirchhoff's first law? So we have to go for the first law equation. The first law equation says that in any node or junction, incoming current and the outgoing current should be equal. So we have to consider this junction or this junction. So if I consider this, the current here should be I1 because the coming here is I1. So if I consider this junction, the ingoing current is I1 and the outgoing currents are I2 plus I3. So if I look at the equation here, yes, this choice A is correct. It's already correct. So choice B not correct because it says all the currents equal. And choice C and D are concerned with the voltages or EMFs. So choice A is the correct choice. But had they asked about the second law, then we have to go through the equations for PDs. So C and D. So what I can have is from this loop I will have E is equal to V1 plus V2. Or from this loop I will have E is equal to V1 plus V3. Both are correct. And if I consider this loop, then I will have 0 is equal to because there is no EMF source here. 0 is equal to it should be equal to V3 minus V2. So if I go from here V3, then opposite, then minus V2. Or if I come from here V2 and the opposite minus V3, or I can say it as V2 minus V3. Had there been second law. So for the first law, this current factor should be considered, and the choice A is the correct choice.